Welcome back. Let's focus this next module more specifically on research and science. Some big words I'm going to try to tackle in a very brief online course. One of my favorite quotes comes from the great statistician Jerome Cornfield, who, when invited to speak about scientific method to an audience, in this case of psychiatrists, many years ago, replied, "On being asked to talk of the principles of research, my first thought was to arise and say, 'Be careful,' and then sit down." I share the same sentiments as the great Cornfield. If I could offer any advice from my own experience and that of which I've read about doing good research, it is to literally be careful, slow down, think clearly, and proceed with great caution. That's how we tend to generate the great evidence that we need. Now, of course, this can be in great tension with all the action you and I want to accomplish. So I think one of the lessons we're trying to impart, or I am trying to impart, is when to go fast and when to slow down. I don't have an overall answer. My advice is just to be sort of mindful of it. Or at first, some great big definitions. What's science? Too tough to tackle here, but I think this is from Wikipedia. Science is an enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the world. So a couple of important points here. We're trying to build and organize knowledge that can be tested to explain or predict phenomena in our world. How do we translate that into the work you and I are doing? We might begin to understand why some communities are suffering more than others. We might begin to understand remedies or interventions that relieve some of this suffering, that may reduce health disparities. Hopefully, some of these remedies are testable. That is, we can say, let's try this. Does it work? How well? For whom? This is the scientific enterprise that we're after in the IRL family. The scientific method is about procedures for searching for the truth. Again, searching for the truth, not confirming what we already know. I'm going to say a lot about this. But remember from our earlier modules, we want to be passionately dispassionate when it comes to our research. We want transparency and replication. These are essential ideas. We can't hide where our data comes from, of course, protecting human subjects properly. We also want to be open to replication. It worked in Chicago. Does it work in Birmingham? Does it work in Colorado? How does it work differently? This is the idea of replication. Can we see if it works? For me, science can also be this childlike discovery. It's this process of seeing the world with new, fresh eyes. What helps that is the training, okay? So the training, a little bit that you're getting here, that all of you have had in different capacities, whether you're formally trained as a scientist or not, it's this training that helps us see these new processes, to make these new discoveries. Training a musician has when she can all of a sudden play a great new tune. Training a mathematician might have when she or he figures something out. A chess player, a baseball player. The training helps us get better and do our jobs more. And so what I want to try to impart in this module is just a little bit of training about the scientific process. Again, for some of you, this will be obvious. For some of you, hopefully, it's helpful. For some of you, it'll be brand new. For me, the key aspect of science is a scientific methodology. Methodological research is concerned with the logic of scientific inference. The objective is to learn what can and cannot be concluded given assumptions and data. Two critical pieces of our puzzle. We're all going to make assumptions, and we're all in some way, be it statistically or qualitatively or observing or photos or anything else, going to be collecting data. We put our assumptions next to our data and make inferences or conclusions. Every study has assumptions. Some studies have good data. We put them together and hopefully we get good conclusions to yield testable or tested scientific processes. Let me revisit the point again. Science is not about marshaling evidence to prove what we already believe or want others to believe. That is not science. Science entails accepting the unexpected even if we don't like the answer. Critically, a scientist, when wearing that hat, again, we can also be activists, but when wearing our scientific hat, we can't be outcome-oriented. We have to be process and principle-oriented. We have to be searching for the truth, whether we discover our intervention helped or not. Again, think about the earlier module when I told that silly story about the prison and not publishing negative results. One thing I like to share with my own students is the distinction between science and research. A researcher might collect information to prove what she already knows. For example, in political campaigns, one might do great research on the opposition. One could find, for example, great things negative to say about Hillary Clinton or Donald Trump. And people in those campaigns, as you surely know, are doing research to find those negative things. That can be really good research, but it's not science. The scientist searches for the truth, would look at all of the evidence, doesn't have a conclusion in mind, though she might hope for one. We might all hope that our intervention work addresses health disparities, but we need to withhold that conclusion until the evidence is in. Sometimes we call that position equipoise, that big word. All it means is we're going to wait until we see what the data say, the data and assumptions. There's all kinds of things we could say about science. Let me just briefly dig in, first about deduction, then some induction, and go from there. The idea of deduction is very simple. Deductive arguments attempt to show that a conclusion necessarily follows from a set of premises or hypotheses. A deductive argument is valid if the conclusion follows necessarily from the premises. What do I mean? It's a lot of big stuff. Well, something like this. Point 1, all men are mortal. Great. Socrates is a man. Therefore, point 3, Socrates is mortal. That's the deductive argument. And so we're going from a set of principles and we end up with a conclusion that must follow. That approach can be helpful in science, but there's another approach as well. And that's induction. That's going from the bottom up, if you will. Inductive inference is reasoning from observed behavior, even if it's a rock. Observed behavior to behavior that might be unobserved. It's a bottom-up empirical process. This work was addressed by the great philosopher David Hume, and he was trying to put things together to understand cause and effect. And there's a whole history here, but Hume's work into induction gave us pause when thinking about causality, that word we worked on earlier in the modules. And so Hume's contention calls into question all the empirical claims made in everyday life through the scientific method, which is generally inductive. But there's more to the story these days. We know more today about the assumptions necessary to say that some X, some intervention, caused some Y, some perhaps reduction in health disparities. When we create our theories of science, one thing we want to think about is, can it be falsified? Can we say, upon testing, this theory did not hold up to research? That's a critical process in the scientific process. If we're not able to falsify a theory, then it may not be a scientific theory. So if we're sure that, say, racism or economic disparity causes some negative health outcome, and we can't test that, then we might be on shakier grounds scientifically. So one of our objectives together will be to think about theories, think about approaches that we can test. One thing that seems quite testable is doing something, improving the neighborhood environment, changing a policy, and then see if that has the desired result, yes or no. So when we actually intervene on the world, certainly the social world, this helps us with this critical notion of falsification in science. Does this drive you a little crazy? It drives me a little crazy too, and I want to scream like my boy did just a few years ago.